If Earth were going to be destroyed tomorrow, where would you escape to? Mars or Proxima b, 4.2 light-years away? The answer may leave you feeling hopeless, because if you choose Mars, Elon Musk's Starship has a maximum payload of only 150 tons. That alone dooms the plan to serve only a tiny fraction of humanity. If you choose Proxima b, the limits of distance shackle us firmly inside this tiny solar system. Although Proxima b is the closest known exoplanet to Earth, it is still 4.2 light-years away. Do you know how long our current technology would need to get there? 1,000 years, 10,000 years. Neither is correct. First, we need to understand that a light-year is a unit of distance, not time. 1 light-year is the distance light travels in a vacuum. In 1 year, about 9.46 trillion kilometers. So 4.2 light-years is roughly 40 trillion kilometers. How absurdly large is that distance? Let's put it this way. If Earth were an ant in Antarctica, then Proxima b would be another ant, standing at the North Pole. In theory, that ant could walk there. In reality, it is almost impossible. That comparison gives you a sense of just how far 4.2 light-years really is. For years, Proxima b has carried humanity's hopes, because it lies within the habitable zone of its star, Proxima Centauri. But because of this, it is also tidally locked to its star. One side always faces the star, while the other side remains forever in darkness. In physics, this is known as perpetual day and perpetual night. True, absolute day and night. The side facing the star is incredibly hot, scorched like food on a sizzling griddle. The far side is unimaginably cold, frozen like a deep freezer. The only place potentially suitable for humans might lie near the Terminator line, the boundary between light and dark, where temperatures could be mild enough and liquid water might exist. But even if that's true, how do we actually get there? The fastest spacecraft humanity has ever built is Voyager 1, launched in 1977. It has been racing through space at about 17 kilometers per second. Even so, it has only traveled 24.8 billion kilometers so far, not even 1 light-year. Proxima b is 40 trillion kilometers away. At Voyager 1's speed, how long would it take to get there? The answer is about 73,000 years. What does 73,000 years even mean? Human civilization, since the invention of writing, is less than 10,000 years old. 70,000 years from now, it's an open question whether humans will still exist at all. Even more depressing, Voyager 1 is the fastest spacecraft humanity has ever sent into space. Although the Parker Solar Probe has reached speeds exceeding 192 kilometers per second, it achieved this only by using gravitational slingshots from the Sun and Venus. If the Parker Solar Probe were to head out of the solar system, would it still maintain that speed? No, because its velocity would gradually decrease under the Sun's gravitational pull, eventually matching that of Voyager 1. Even if, one day, Voyager 1 somehow reached Proxima b, humanity might have long forgotten that Voyager 1 ever existed, because within the next couple of years, it will lose contact with Earth. Its nuclear batteries are nearly depleted, and all of its instruments will shut down. From then on, it will become a wanderer of the cosmos. Though it will keep drifting onward by inertia, it will never again be able to say hello to its home planet. The golden record it carries may, in 10,000 years, become nothing more than a relic proving that human civilization once existed. Many people ask, why don't we just build bigger rockets, faster spacecraft? The truth is, you can't really blame the engineers. The Tsiolkovsky rocket equation is a brutal mathematical curse. At its core, it is a cosmic version of the moving bricks paradox. Every kilogram of fuel you carry requires even more fuel to push it. Let me give you a number. To accelerate a 1-ton probe to just 10% of the speed of light, about 30,000 kilometers per second, you would need more fuel than exists in the entire solar system. Measuring the universe with rockets is simply impossible. Just when despair set in, the idea of laser sail spacecraft emerged. The core concept is simple. Use an ultra-thin, highly reflective sail, and fire an extremely powerful laser from Earth, precisely aimed at the sail. Photons have no mass, but with every collision against the sail, they deliver a tiny yet continuous push. Over time, that push accumulates, the sail accelerates. In theory, it could reach 20% the speed of light. If that were possible, reaching Proxima b, 4.2 light-years away, might take only about 20 years. But turning laser sail technology into reality is far more difficult than it sounds. First, the sail material must meet extreme requirements. It has to be unimaginably thin and light, so its own mass doesn't cripple acceleration, yet strong enough to survive prolonged, intense laser bombardment without tearing apart. Second, laser power is critical. Only lasers of staggering strength can provide enough thrust to push a sail across interstellar space. Finally, deployment and control are just as crucial. The sail must unfold perfectly in space. Any failure during deployment, or any loss of control during flight, could doom the entire mission. Physical laws may feel like towering walls, trapping us inside the solar system as a perfectly designed prison. But don't forget, humans are not the obedient type. We are natural escape artists. Back in the 1960s, using computers weaker than a microwave oven, we still managed to land humans on the moon. By 2025, we built the James Webb Space Telescope, capable of directly imaging exoplanets. From Voyager 1's lonely drift to laser sails chasing light itself, our curiosity about the universe has never stopped. Every technological breakthrough is a giant step deeper into the cosmos. We admit it. Interstellar migration won't be easy. Maybe laser sails won't succeed. Maybe controlled nuclear fusion will take decades longer. But we have already touched worlds beyond Earth, and that means we should believe that, one day, we may discover new physical laws, or invent entirely new forms of interstellar travel. No matter how many obstacles lie ahead, the human drive to explore will be passed on, and maybe, just maybe, 100 years from now, human footprints will rest on Proxima b.